Hello, ladies and gentlemen. Welcome to today's video. Today we will go for rate of reaction. So for this chapter, we will master first rate of reaction about the solid, surface area, liquid, concentration, gas or pressure, temperature, catalyst. These five factors, how can they affect the rate of reaction? And then we also learn about the reversible reaction and equilibrium situation, how temperature and pressure will affect it. Before we go to all these factors that affect it, let's talk about how we practically do this experiment. To investigate the rate of reaction, we can either see the changes in mass of the reactant or product. We can measure the mass by using the balance. Gas is released, the mass of reactant will decrease. Or we can collecting the gas. So when gas is forming, then the volume of gas will push this. Then we can know what is the volume of gas that it produces. The questions talk about calcium carbonate react with acids. It releases carbon dioxide. So we are using the gas string to check this. So which measurement should we take to determine the rate of reaction? We need to collect the volume of gas and rate. We must measure the time. Then we can measure the rate of reaction. So after we collect the information, we can sketch the graph like this. Then we can analyze the rate of reaction by gradient. The gradient of the graph shows the rate of reaction. Which time rate of reaction is greater? So when it's 0, no rate of reaction. When it's 4, it's almost like this. 6 is around like this. And then 10 is very flat. This is steeper, so answer is C. Next question, the graph shows the volume of gas produced against time. How does the shape of graph shows that rate of reaction decrease? Previously, we already know we see the rate of reaction based on the gradient. So here we just mentioned the gradient gets less. Next question says, after how many seconds did the reaction finish? So we can confirm at this moment, gradient become flattened horizontal. Then we can confirm at this point, the reaction finished. So it's 120 seconds. Okay, next we officially go to the factors that affect the rate of reaction. Previously, we mentioned we have 5. We talk about these 3, which is in solid surface area effect. So when the surface area is larger, for example, if you have a big cube, you cut it into very small cubes. They have the same mass, but can you see the surface area of the smaller cubes have larger surface area? So when have larger surface area, possible to have more frequency of collision. Okay, second factor, we talk about liquid. When the concentration is higher, then the collision will be more frequent. Let's say this is a dilute acid. This is a concentrated acid. I might have 2 HCl in this region, but the concentrated, I have many HCl. So that's why in the concentrated situation, it's very easily have particle collision. So this is concentration of liquid can affect. Same goes to the pressure for a gas. So if pressure is very strong, means that we compress it and the particles is very compact. That's why high pressure will have more particles in a specific volume. That's why higher pressure for gas, higher concentration for liquid, and higher surface area for solid will increase the frequency of particle collision. That's why increase the rate of reaction. So let's see the past year question. The experiment is repeated by using powdered zinc instead of lumps of zinc. Powdered zinc, the surface area increase. All other conditions remain the same. Explain in terms of collision theory why the rate of reaction increase if powdered zinc is used. First, you just tell me powdered zinc have higher surface area. It increased frequency of collision between particles. Too much. Which statement explains why increased concentration increase the rate of reaction? So A, it says a greater proportion of particles have activation energy. This will only affect by catalyst. We will see later. So it's not A. Particles have more energy. This is increased temperature situation. We will learn later. 3, they are more particles in the same volume. Yes, concentrated, there are more particles in a specific volume. That's why increase the frequency of collision. So you see. D, the particle moves more quickly. This is also caused by temperature. So no. Next, Powdered magnesium carbonate is added to excess HCl, so the total volume of gas is produced. A graph of the result is shown here. The experiment is repeated, but the concentration of HCl is doubled. So all other conditions keep the same. Which statement about the second experiments are correct? So when concentration increase, frequency of collision increase, so the rate of reaction increase, so the stiffness will increase. So which statement about second experiment correct? It says the final volume of gas is 360. No. Even though the concentration is increased, but the number of mole they do not say they change. So that's why the final volume will still remain as 180. 2. The reaction finished before 90 seconds. So initially it's around 90 seconds. If we increase concentration, rate increase, then it will finish faster before, correct? The activation energy is lower. No, the activation energy only affected by catalyst. So answer is just donkey. Next, a student adds excess magnesium ribbon to sulfuric acid. The hydrogen gas produced is collected and its volume is measured every 10 seconds. The experiment is repeated with this amount. Same concentration, so same rate of reaction, but lesser volume means number of particles is lesser. So that's why the final product volume will decrease. Which line of graph shows the result of the second experiment? So original experiment is like this. So the rate of reaction would be the same. So won't be faster, won't be slower. And then product volume will reduce because we have lesser reactant. So answer is just D. Next, students carry out experiment, use zinc with H2SO4, measure the volume of hydrogen produced. Lumps of zinc are used. Rate of reaction decrease as the reaction progresses, eventually becomes 0. Explain why the rate of reaction decrease as the reaction progresses. Zinc plus H2SO4. Initially, we have this amount of H2SO4, but when we start experiment, we continue to produce product, and the concentration of reactant is decreasing. They are converting to the product. So that's why if the concentration of H2SO4 throughout the experiment reducing, then the rate of reaction reduces also. Okay, so concentration, sulfuric acid decreases, frequency of collision decreases. Explain why a rate of reaction eventually 0, because the acid used up. Okay, next we talk about the rate of reaction of another 2 factors. These 2 factors, I do it separately because the way that it changed the rate of reaction is a bit different from the first 3 reasons. So that's why we study separately. First is the temperature. We always know that we increase temperature can increase the rate of reaction. Why? First, temperature increase, kinetic energy of particles increase also. When you heat it, the particles will move faster. That's why kinetic energy increase. And when kinetic energy is stronger, they will move faster. That's why the frequency of collision also increase. Not only this, not only it increase the frequency of collision, for temperature, when they increase the energy, when they collide, the collision also have higher energy. That's why you can say there is a higher percentage of collision that achieve or exceed activation energy. Activation energy is the minimum energy that reaction can happen, because not all collision can have reaction. If they do not achieve a sufficient energy, then nothing happens. So that's why this reason is very similar to the concentration, surface area, and pressure, because it increases the frequency of collision. And one additional information is about the energy and the percentage of collision that have sufficient energy. Okay, how about catalyst? In the previous question, we already mentioned catalyst will decrease the activation energy. Let's say this is the reactant, and then the energy that required for it to reach reaction, this part we call activation energy. Catalyst can always reduce the activation energy. If you put catalyst, the reaction only need to achieve this amount of energy, then they can form the product. Because of this decrease of activation energy, it can cause higher percentage of collision able to achieve activation energy. That's why the rate of reaction increases. Other than this, the question might also ask, what is catalyst? Catalyst is a thing that increases the rate of reaction and it unchanged at the end of reaction. Means that catalyst is speed up the whole process, but itself won't involve. So that's why at the end of the experiment, you can gather back your catalyst. The catalyst do not change to any other compound. So which statement explain why increased temperature change the rate of reaction? It increased activation energy? No. The only thing that can affect the activation energy is catalyst. It can reduce the activation energy. It increased the frequency of collision. Yes, because it moves faster, kinetic energy higher. It increased the kinetic energy of the reactant. Yes. Higher percentage of collision can achieve the activation energy. Increase the number of particle per unit volume. No, number of particle per unit volume. This is concentration of pressure. So only 2 and 3. Next question. The effect of change in condition on chemical reaction are listed. The total number of collision per minute increase. This is increased rate of reaction. The number of effective collision increase. The average energy increase. Okay, so the only reason that increased energy is increased temperature. D, very obvious. Next, the experiment is repeated with an increased temperature. Explain in terms of collision theory why rate of reaction is higher when increased temperature. So first, kinetic energy of particles increase. When kinetic energy increase, they move faster, so frequency of collision between particles also increase. Then we talk about the percentage of collision that achieve activation energy is also increased. Next, the student repeat the experiment at a higher temperature. All other conditions stay the same. The rate of reaction increased. Ask you to draw a line to show that it's in higher temperature. So higher rate of reaction means that it's steeper. The final product amount is the same, just like this. Next, the equation of decomposition of this is shown. In an experiment, the total volume of oxygen produced is 100 cm3. The experiment is repeated using 1 gram of catalyst, which should describe the total volume of oxygen. So add catalyst only increase the rate of reaction, won't affect the total volume of the product, so it will remain 100. The mass of catalyst at the end of the experiment, catalysts do not involve, full catalyst will remain there, so it's still the same, so it's just C. Okay, so after we deal with 5 factors that will cause rate of reaction change, next we talk about equilibrium. Equilibrium situation will only appear for reversible reaction. For example, nitrogen plus hydrogen will become ammonia. A reversible reaction means it's not fully 100% form ammonia. A certain percentage will remain in nitrogen and hydrogen. So the first thing that you need to know is when equilibrium happens. Equilibrium happens when the rate of forward reaction and backward reaction are the same. So the main thing is the rate, means nitrogen H2 go to NH3 is the same rate as NH3 go back to nitrogen and hydrogen. Second point you need to tell me is the concentration of reactant and product will remain constant. So when your reaction reach this phase, then they are in equilibrium state. So when they reach this equilibrium, you can't change the percentage of ammonia anymore. So there are 2 methods that can change this stable state, which first, temperature change. So temperature change will have different effect, depends on whether your forward reaction is exothermic or endothermic. What is the meaning of endothermic? Endothermic means they need to absorb energy from the surrounding. Endo. If you increase temperature, then they can absorb more happily, agree or not? So when they absorb more happily, they prefer to shift to the right. So that's why the percentage U of the product will increase. Equilibrium shift right. But if the forward reaction is exothermic itself, they will release heat to the surrounding, and then you still supply them more energy they don't like. That's why they will prefer to shift back to the left. Second, changing the pressure. Higher pressure always favors lower number of particles, because when I increase the pressure, you have a lot of particles, then it's very squeezy. So that's why it tends to become lesser number of particles. So we see on the left hand side, we have 1 mole of nitrogen and 3 mole of hydrogen. So total 4 mole. But the right hand side, I have only 2 mole of product. So if I increase pressure, they will tend to choose 2. That's why shift to the right. So this is the 2 factors that will affect the changes in equilibrium. Okay, let's see the question. The reaction that produces sulfur trioxide is equilibrium. The fourth reaction is exothermic. Describe 2 features about equilibrium. First, rate. Okay, second, about concentration. Next, state the effect, if any, on the position of equilibrium when the following changes. The forward reaction is exo. Exo release heat. So when you increase temperatures, they are not happy, they will shift back left. Next, the fourth reaction is endo. State what happened to the position of equilibrium when temperature decrease. Forward reaction endo, they prefer you supply higher temperature. So your temperature decrease, they are not happy, so they will shift back to the left. State what happened to the rate of forward reaction and backward reaction. Here they specify, they want the rate, nothing to do with the equilibrium shift left or right. They ask about the rate. So temperature decrease, any rate will decrease, because lesser temperature, lesser kinetic energy. So the rate confirm decrease. The question says, carbon and steam will form hydrogen. The fourth reaction is endo. So which role describe a change in pressure and temperature that both shift to the right? Okay, we talk about endo first. If you want to shift to the right, then endo prefer you increase the temperature so that it can absorb more. So temperature must increase. Second, we want to shift to the right. Then we compare left and right. How many number of mole of gas? On the right, we have 2 mole of gas. Left, we have only 1 mole of gas. This carbon solid will not affect because it's not a gas. To shift to the right, more particles. Pressures must decrease so they can prefer higher particles. Okay, so answer is B. Next, sulfur is converted to sulfuric acid. How will this affect? If we add a catalyst, effect on the rate, catalyst will surely increase the rate. And then the catalyst will it affect the equilibrium yield? No, equilibrium only affect by pressure and temperature. Next, increase the pressure. For the rate, it's always increased because more particles in a specific volume. But equilibrium yield, we need to see the number of particles on each side. Here, 3 mole, here 2 mole. So if we increase pressure, it will prefer lower number of particles, so it will increase. Okay, complete the table by using the words increase, decrease, or no change. Increase temperature, rate confirm increase. For equilibrium state, usually they will tell you, but this question they do not tell you, but they say increase temperature will increase the Cl3 and Cl2 means that it's actually an endo. Next, decrease the pressure. For the rate is confirmed decrease the rate. For the effect of equilibrium, we need to compare the number of moles of gas. So left hand side have 1 mole, right hand side have 2 moles. So decreased pressure will favor higher number of particles. So it will increase. If add a catalyst, rate will confirm increase, and then it won't affect the equilibrium. Next, the table shows that when temperature increase, the equilibrium yield increase. What conclusion can you make? When temperature increase, the forward reaction will shift right, means that they like the higher temperature. So the forward reaction is endo. Next, dinitrogen tetraoxide is converted into nitrogen dioxide. Reversible reaction. Forward reaction is endo. Which condition give highest yield of nitrogen dioxide? So endothermic means the temperature we need to increase. Then it will favors shift right. And then the pressure, then this thing we need to base on the number of particles. 1 mole, 2 mole. So they prefer lower pressure. So answer is A. Okay, last we see one more situation for equilibrium. We are talking about if we change the volume for any of the substance, after they reach the equilibrium, will it disturb the equilibrium? Yes. For example, this question they say is they add the water to this solution. What is the observation that you see? Okay, if the volume of H2O increase, when here increase, it disrupt the equilibrium already. So here have too much. That's why it will tend to shift to the right. So that's why you see the color will change to pink. Move right or shift right. Another student's cool a blue solution of this. The blue solutions turn pinks. What does this information indicate about the forward reaction? So cools. And if we prefer forward reaction, means that the forward reaction is an exothermic. Okay, so it's the end of this chapter. So we already covered 5 factors of rate of reaction, 2 factors that affect the equilibrium, and if we add water or add any reactant, will the equilibrium change? Yeah, we already complete this. So I hope you learned something in this chapter, and please don't forget to subscribe, like, and share my video. And if you have any question, please comment here. Thank you. See you in the next class. Bye-bye.